In this presentation, I'll go over the solutions to several questions that we haven't covered so far in the class. The topics covered by the questions are important for the exam. The first question that I'll cover is the second sample exam question that I sent out earlier this week. In that question, you're asked to write a recursive string comparison function. The other question that I'll cover comes from tutorial number 8, which is about the MyString1 class. When we covered that, we weren't quite ready to write the copy constructor and assignment operator for the class, so now we'll take the opportunity to review copy constructors and assignment operators by completing that question. So to begin, I'll review the string comparison function. strcomp takes two strings and returns an integer. The integer can be three values, -1, 0, or 1. The value -1 is returned if the first string is less than the second string, where less than is defined by lexicographic order. That's just a fancy way to say that it compares character by character and compares ASCII values. The return value for strcomp will be 0 if two strings are equal, and the value will be 1 if the first string is greater than the second. So using that information, try to guess what the output of these cout statements will be. So here's the solutions. In the first example, we have strcomp of the string 2 and the string 4. Because strcomp will compare character by character, it'll take the character 2 and the character 4 and compare their values. Because the ASCII value of 2 is less than the ASCII value of 4, the result will be a -1, saying that the first string is less than the second string. Similarly, for the second example, because the strings are equal, it'll return a 0. And for the third example, because string 4 is greater than string 2, the value returned is 1. For the fourth example, we're comparing the string 11 to the string 1,000,000. This is where it's important to remember that it compares character by character, going from left to right. The first character of each string is 1, so they're equal so far. For the second character, the first string is 1, and the second string has a character of 0. So because 1 is greater than 0, strcomp will return a value of 1, saying that the first string is greater than the second string. In the fifth example, the string high is compared to the string hill. And the first two characters of both strings are equal, and because the first string only has two characters, it's less than the second string, which has more than 2. In the last two examples, the second last, the strings are equal, so a value of 0 is returned. And in the last case, the first two characters are equal, but the first string is longer than the second, so it's greater than the second string. Now that we've reviewed what strcomp does, try to write the recursive definition of strcomp. Here is the solution that I came up with. Remember that recursive functions always have stopping conditions and a recursive call. They can also have error conditions, but in this case I didn't need it. The stopping conditions work by checking the character pointed to by S1 and S2. Because S1 and S2 are pointers, to get the character that they point at, you have to dereference, or write *S1 and *S2. The first condition is checking if S1 is less than S2. That can be true for two reasons. If the character pointed to by S1 is less than the character pointed to by S2, or if S1 is pointing to a null terminator and S2 is not. That's the case that we saw in the examples where S1 and S2 were equal for the first few characters, and then S1 finished, but S2 had more characters. So if either of those conditions are true, a value of -1 is returned, stating that string S1 is less than string S2. The opposite conditions are tested in the else if statement. Those are the two cases where S1 is greater than S2. In the final else if statement, I check if both strings are terminated. If we think recursively, and we manage to get to this condition, that means that the strings have been equal so far, and they both now terminate, meaning that the strings were equal, so a value of 0 is returned. The only case that's not tested by the if else if statements is if *S1 equals *S2 and they're not equal to \0, or null terminators. In that case, we need to continue comparing, so we use a recursive call, but we advance S1 and S2 by passing the arguments S1 plus 1 and S2 plus 1, which will do pointer arithmetic to advance to the next character in the string. The next question is about MyString1, and if you remember, MyString1 had the problem that it was using memory on the heap, but it was using the compiler-generated copy constructor and assignment operator. This allowed two objects to be pointing to the same location on the heap. As a result of that, near the end of the program, there was a double free error message. This slide gives several ways to state that problem. I guess remember that shallow copy means member-wise copy, and the law of big three states that if you define any of the three, copy constructor, assignment operator, or destructor, you should define the other two. In this example, the destructor was defined, but not the copy constructor and assignment operator. And that brings us to this exercise where we're supposed to write the assignment operator and copy constructor. So take a few moments to declare the assignment operator and copy constructor, and then we'll define those functions after we declare them. Okay, so here's the MyString1 copy constructor and assignment operator declarations. First, the copy constructor is a constructor, so the function name is just the class name, MyString1. And the copy constructor is different from other constructors because it takes a reference to an object of the same class. That object that I'm calling S is const because we don't want to change S inside of our constructor. The declaration for the assignment operator is a bit more complex. First, it has a return value which is a reference to an object of the class, and the function itself is called operator equals. And it takes an argument which is a reference to an object of the same class, and it's passed in by const as well because we don't want to change that. So now try to implement these two functions. Recall that MyString1 has two data members. One is an integer called lengthm that tracks how long the string is, and the other is a pointer to a character, which is the array on the heap that stores the string inside of MyString1. And that member variable is called storageM. First, here's the copy constructor, and notice that for the definition, this would be inside of a CPP file, whereas the declaration would be inside of a .h file. So because we're outside of the class declaration, we need to use the scope resolution operator to tell it that it's a member function. That's why we see the first MyString1, and then the two colons, and then another MyString1, which is the name of the function. First, the member initialization list is used to set lengthm to s.lengthm to make the strings of equal length. And then inside the body of the constructor, a deep copy is performed. That means that new heap memory is allocated. And also note that you allocate lengthm plus 1 because you need extra space for the \0. And then lastly, the string copy function is used to copy the contents of s.storageM into the current object, storageM. The definition of the assignment operator is somewhat similar, but there's always three parts to the assignment operator. The first part is that you compare this to the address of the reference that's passed in. That's to check that you aren't assigning to yourself. Then inside the body of the if, you do a deep copy, but first you should delete your current storageM, or else you'll have a memory leak. Also note that we're using the array version of delete. And lastly, because the equals operator returns a reference, you always return *this, or a reference to yourself. In this presentation we reviewed strcomp, which can return -1, 0, or 1, depending on if the first string is less than the second, the two strings are equal, or if the first is greater than the second. Then we got some practice with recursive functions by doing a recursive definition of strcomp. And lastly, we wrote the copy constructor and assignment operator for MyString1. That was to avoid the problems associated with heap memory and compiler-generated functions.